Hi, and welcome back. My name is Kim, and today I'm going to teach you another science lesson. So today's experiment is called Walking Water Rainbow. And so what you're going to need for this experiment is you're going to need 6 glasses. It's ideal if they have a wide mouth on them and they're kind of short. You could use little mason jars or something like that. I stole these from my father's bar, and I'm going to meticulously put them back later so he never even knows. But again, not good role modeling, so don't do that. We're also going to need some food coloring. So we're going to use the primary colors. So if you've learned about those, we're going to be using red, yellow, and blue food coloring. So the very first thing that you're going to do is put some drops of food coloring into 3 of the glasses. So the red's going to go into the first one, then the yellow is going to go into the third one, and then blue into the 5th one. And then you're going to have 3 glasses that are going to stay just clear water. And the purpose of this is so that we can see the colors traveling, and hopefully, if it works properly, they'll actually mix, and we'll get to see some secondary colors. So once you have your food coloring in the glasses, you're going to fill it with water. Now I already did this step. As you can see, all my glasses are full of water, and they look really pretty. The next thing that you're going to do is grab some paper towel. It's ideal if it has the little perforations right here, but if it doesn't, we'll work with whatever you have at home. But I picked this experiment because I know a lot of families have a surplus of paper towel at home right now. So what we're going to do is fold it into about 3. If you do have a bigger roll with larger sections, then you can just fold it however you think is best. Maybe do a little bit of cutting. And then what you're going to do, and this is really important, is you're going to cut it to be short enough for your glasses. So we're going to put it like this so that it kind of curves over the top of the glasses. We don't want too much space here or too much air, and it'll make sense a little bit more in a second, but you want it to be just enough to pass over the glasses and still go inside them. So that's what that looks like. And now what we're going to do is actually turn our glasses so that we can put them into a little circle. Being very careful not to spill these on my mom's tablecloth, which I've already done several times. Love you, Mom. Okay, so now they're all set up this way. So what we're going to do now is put our paper towels in. So as I mentioned, curved over, we're going to start with the red one. So we'll put one end in the red and then into the clear as well, making sure it goes really deep in there. And you're already going to see that it's kind of already traveling. And we'll take the next one into the yellow. Okay, so all your paper towels now should be in your glasses if you're doing this with me, and I'll show you what this looks like. So the next step of this process, the actual walking, the water is going to do all the work itself, but we do have to wait a little while to see the full results. But I'll explain to you a little bit about what's happening. So, do you know what paper towel is made of? I'm going to assume that you said the right answer because you're all so smart. So it is made of plants. And so specifically in those plants, there's cellulose. And those cellulose fibers are what makes up the paper towel. And that's why it's so absorbent. And it soaks up all the water from our messes or whatever we spilled. So just like in real trees, you've probably wondered, how does the water get all the way from the roots all the way up into this huge tree, right? Well, it's a process called capillary action, and that's actually what's happening in our little mini experiment today. So capillary action, in trees, the water moves through capillary tubes and it slowly moves up, up, up the tree. And in this experiment, a similar thing is happening. So the water is filling those tiny spaces between all the different cellulose fibers, and that's helping it move along. Additionally, we have 2 other kind of forces at work. Actually, we have 3 forces kind of at work. So we probably know what gravity is. You've probably heard about it. It's kind of what's holding everything down to the earth. So, for example, if I drop this pen, if I really drop that pen, you saw it fall down, right? That's a force of gravity at work. It pulls things back down towards the earth. So we have that force that's kind of working against the trees and the water while the water kind of tries to move up. But we also have two amazing forces, and that's why water is such an amazing substance. We have cohesion, and we also have adhesion. So adhesion is the ability of water to stick to other materials. Water is a very, very sticky substance. So in this case, it's sticking to those cellulose fibers and it's attaching to them, and that helps it walk up. Additionally, the other force at work is cohesion. So not only is water sticky towards other fibers and substances, it's also sticky to one another. So it's like all the water molecules are just best friends and they always want to stick together. And so that helps capillary action, and it helps water move up trees or move up plants because it's sticking to one, the fibers, but then also as it sticks and moves, it's bringing all its friends up with it. And so that's what we're seeing happening here in this experiment. So if you're doing it at home with me, you can probably already see that the colors are starting to move. We're going to give it a few minutes. We'll take a little break, we'll get a snack or something, and we'll come back. It should take about maybe 5-10 minutes, depending on how big your cups are. If you're not seeing it moving, there could be a couple things there. Definitely add some more water. It's important that the water is quite full in the cups, and that way it doesn't have as far to travel, right? And so the gravity is not as much of a force on it. So that's one thing you can try. So yeah, we'll pop back in a moment and see what's happened. Welcome back. Hope you enjoyed your break, got a snack, refueled that brain to do some more science. So I'm going to share with you a thing that I learned in the last 15 minutes. Another really important thing that I failed to mention is how important it is that your glasses are very close together. Because now my mom also has a beautiful tie-dyed tablecloth. So, sorry Mom. But it worked and they look so beautiful. So I'll give you a close-up shot as well. But as you can see, even just from the front here, our colors did start combining. So now we can see that our yellow and our red food coloring made an orange. And here our blue and our yellow, they made a green. And our red and our blue here made a purple. Purple looks a little bit scary, but they're all there. So I hope you had a fun time learning with me today. I'm sorry to all the parents out there, the caregivers whose tablecloths I just ruined, but I hope you had a lot of fun. So I'll see you next time. Bye-bye.